Our next practice on ANOVA is on an analysis of a data set of second-hand cars. So we have taken a web page of a German web page where they sell second-hand cars, and then we have recorded, they have recorded a number of variables like we have them here. So what is the price of the car in euros, whether there has been a test before selling the car or not, the vehicle type, the year of registration, the kind of gearbox, the power of the engine, the number of kilometers and number of kilometers of the car, month of registration. So we foresee that probably that doesn't count for very old cars, but probably for newer cars it makes a difference. And then also the fuel type, the brand, and whether there are some damages that have not been repaired. So our purpose is to explain. We will use on ANOVA alone. So our purpose is to predict the price based on ANOVA and based on discrete variables that are the ones that ANOVA can handle. Okay, so let's see if we succeed in that. Okay, so the first thing is to have a summary of the variables so we can see what we have there. So we have the price that goes from 0, which is a little bit strange, to 2 times 10 to the 9 power. So this must be some mistake, because there cannot be a car that is so expensive. And then most of the cars, or it is half if we want. So what we see is that there are many cars. So we have in the order of 200,000. And then vehicle types, there are different vehicle types, and well, whatever they are. And then year of registration, they go from very old cars to pretty new. Then gearbox, most of them are manual. Then the power of the engine, and again, this must be some mistake because that doesn't exist. And then number of kilometers, month of registration, and fuel type. We have again many different fuel types. Most of them are standard gas, and then the second ones are diesel, and then there are like under minoritarian groups. And then the brands, there are many different brands, many Fords, many Mercedes, Opel, well, whatever they are. And then most of them don't have any damage to be repaired, but a few have. Okay, so this is what it is. Then let's have a look at some of the plot so that we understand better what we have in there. So what we have is well, this price that goes to 10 to the 9. Here is the price again. So this is really distorting a lot. And the same with the power. So we see that this power of 20,000 power horses, this is impossible. So okay, so what is interesting is that at the beginning of the year there are fewer cars that are sold. This is something that probably resellers of this market knows. And okay, so let's see, let's remove the outliers, and for doing that we will take the 2.5% of the smallest and highest values in a number of variables. Even the year of registration, we have this 1910 car that probably doesn't is not representative. Okay, so let's make the plot again. Now it looks much more standard. So the price, we see that it is not Gaussian at all, for instance. So it is a very curved or very skewed distribution with a very long right tail. But most of the cars are somewhere here at a value around 12,000, 13, 14,000. And I don't know, this is number of cars, I think. This, well, I'm not sure. And then, well, we have the year. That years go from 1990 to 2018. And we have this pattern of the months. The number of kilometers, we see that most of them, they have reached this 150,000 kilometers. So it seems that is a number at which they normally sell their cars. The power is not uh, something more Gaussian, not exactly Gaussian, but it has more the shape of a bell. And this is also interesting, especially this relationship between years and 150,000 kilometers, because it seems that most of the cars are sold at these when they reach this number of kilometers, and we see that most of the cars that are sold are from these years, meaning that that is the number of years that takes to do this number of kilometers. Okay, so now let's look at the categorical variables. So we have a few of them. So we have this is the box plot of the price as a function of the different vehicle types, of the different fuel types, whether they have some damage to repair or not. We can see that if they are damaged, they're cheaper. And then whether they are automatic or manual gearbox. So automatics, they are more expensive, or at least, yeah, they're more expensive because the median is higher, but they have a wider range. So, and this is the same box plot, but this is price. This is the different brands, and most of them are somewhere here. Some of them are a little bit more expensive, a little bit less expensive. There are really two outliers. One is Land Rover. Land Rover has a very wide variety. The other one is Porsche. Porsche, again, they can be really, most of them are really expensive. Okay, so now we understand the data. So let's try to construct our first ANOVA. And to start simple, we will try to explain price as a function of the vehicle type. And then we will see whether a few plots and the ANOVA table to understand this relationship. So let's start with the well, the ANOVA table is here. It is here. So what we have is the total sum of squares, and we see that the different groups explain a fraction of them, and it is extremely significant because all this fraction has been explained with only 7 parameters, while all this amount of sum of squares have been explained by these many parameters. So each one of the parameters in the groups of vehicle types explains 4,000 times more than each parameter of the residuals, and the p-value is extremely low, and it is rounded to 0. So we see that the price effectively depends on the vehicle type, and then we can see here how are those dependencies. So this is the price, and the box plot of the prices as a function of the of the different vehicle types, and certainly they depend on the vehicle type. Okay, so let's see what are the contributions of each one. So the contributions of this is Adler, this is bus, cabrio, coupe, Kleinwagen, or whatever. So this is beta 0 plus beta 1 when x takes the value SUV or limousine or combi. So here we have the effect of both. So this number is just the sum of the two. Here what we have is an interactive plot where we can choose for every kind of car. We can choose, we can click on it, and then this bar is related to the confidence interval of that estimate that we have seen on the console, and how different they are. So this one is different to all other groups. So the price of each one of the groups is really different to all the rest. We can see, and we will see later some other examples where some of the groups are not significantly different, but in this example all groups are significantly different. The cheapest cars are this one, the small cars, the Kleinwagen, and then the most expensive cars are these ones, the cabrios. And well, okay, so now we have a price as a function of the vehicle type. So let's see now price as a function of month. We wouldn't expect this to depend too much, but let's see. Okay, so we may remember that before the sum of squares explained by this vehicle type was 10 to the 11. So let's see now. So now we can look at the ANOVA table. Now the sum of squares is 10 to the 9. So this is much smaller. And we see already this translated into the F. So the F before was 4,000, now it is only 13. So it is significant. So not all the months are equal. So here are the box plots per month, and they look pretty much the same. But we know that there must be differences, and here are the differences. They're not big differences. So these differences go from 5,000 euros to 6,000 euros. So it is only about 10% of difference. But we see that the cars that are that were registered in November, they tend to be more expensive, and the reason is that they are newer. And surprisingly, January is more or less in the middle. So we said that this graph is interactive. So this means January is significantly different from March and November, but they are not significantly different from the rest of months. They are gray because they are not significantly different. If we choose this one, so now this one is not significantly different from this one, but it is significantly different from the rest. So this is a little bit surprising. So cars that were bought in March and December, they are a little bit cheaper. The same a little bit for February. Then we have all the middle, all the rest of months, they are more or less the same. And then the cars in November, they are a little bit more expensive. So the difference is not much, but this 10%, depending on what is your business, may make a difference or not. Okay, so but we already saw that the big part of the variance is explained by the vehicle type, not by the month. So this one, the sum of squares, was explaining 10 to the 11, while this one is explaining only 10 to the 9. Okay, so now let's put vehicle type and month of registration together. Okay, so just to explore the possibilities of two-way ANOVA. So we explore these, and we have a lot of figures. Let's come back later to them. And then this is what we get more or less the same results as before. So the vehicle type is explained in 10 to the 11, month of registration 10 to the 9. They're significant, almost the same values. And there is a little difference because when the amount of variability explained by the error, now it is smaller because we have included the month of registration, but still it is not so much small so that as to significantly change this f. So normally when you make the error smaller, the f goes up, so they must be a little bit larger than the ones before, but not so much. Okay, so here we have the same plots that we had before by type of vehicle, by month, and now here we have the combinations. So the combinations, because we have so many combinations, they are very difficult to read. But here, for instance, what we have is other type of vehicle, month 1, and then vehicle type equal bus, month 1, and so on. So we have all the months from 1 to 12, and then all the different vehicle types. And again, for instance, here now we see that the price of a car bought in January, or this other types of car, they are not significantly different. So we have here 12 bars, meaning what are the different months. So for the other vehicles, they are not significantly different along the year. Let's see these ones. So the second type of car, or I don't know which one this is, but because we cannot see there. But for these cars, the prices are a little bit different, but not significantly different except for this month. So this may be just a matter of chance, or it might really represent something that is substantial to this market. Okay, so this is for the two-way ANOVA that has more or less the same interpretation as we had before. And now we will include the interactions between vehicle type and month of registration. So the model before didn't have any interactions, so it was just the beta 0 plus beta 1 depending on the vehicle type, plus beta 2 depending on the month of registration. Now we include interactions depending on both, and we do that by adding this flag or this argument to the function ANOVA. Okay, so now let's run this section, and we have the same kind of plots that we had before. Now they are equally clustered, but or cluttered, let's say. So they're difficult to read. Let's see whether the interactions are significant or not. So it seems that they're significant, these interactions. They don't explain much, but they explain much more than the month of registration alone. So well, not much more, because we have more number of degrees of freedom. So each parameter of these interactions explain, well, not that much smaller, so it is like 20-30% smaller than this one, but still it is relatively significant. So it is significant because the value is smaller than is very small, but it is not as significant as this one, as the month of registration. And obviously the most important variable is the vehicle type, that is explained in 10 to the 11. Okay, so Here we have also the different combinations. So yeah, so this is constant, this is the beta 0, and then the contributions for the different kinds of beta 1. Then for beta 2 we see that these are much smaller than this, and this is expected because this is explaining 10 to the 12, this is explaining only 10 to the 11. And then we have the interactions, and these are the interactions. We have many interactions. Okay, so then let's put more variables. So let's put vehicle type, month of registration, and gearbox. And here we are getting the full model, so with all interactions. And this is another way of plotting that. Okay, so and then at the end we are using here the function ANOVA n, but we could have also used the function fit LM, fit linear model. And here in the fit linear model, we put all the kind of interactions that we want. Okay, so we will have two different kind of reports. One is the ANOVA table that is given by ANOVA n. The other one is the one of fit LM. Okay, so let's do both together, and we will get interesting information from both of them. And okay, so this should be coming. Okay, it takes a while to compute. Here it is. So we have all this cluttered plot that it is impossible to see anything in there, but we understand what they are. So these are the differences per month, and we see that, for instance, this month is significantly different from this ones, and then the differences by number by the vehicle type, and here we have, sorry, here we have all the different contributions. So here we have the vehicle type that we know it is explained 10 to the 11, and then the other one that is very important is this vehicle type and gearbox. This is explaining again a lot, and this one also, the gearbox. We see that it explains also a lot, and we can look at that through the F. So the most important F is this one, and this one so vehicle type and gearbox, those are the ones that determine the price, and probably we have here different contributions. So I think this is from the previous one. Oh no, this is the current one. So we have the constant, that is 7,000, and then the contributions, the beta 1s for each one of the vehicle types, and then the beta 2s for the different months. And we see that there is a difference of almost 3,000 euros between an automatic car and a manual car. And so if you are automatic, you get beta 0 plus this amount. If you are manual, you get beta 0 plus this or minus this amount. So the difference between both kind of gearboxes is 3,000 euros. Well, this is a lot of money, probably. And then you have all the different interactions. So you see that some of them they really make a difference. So for some others there is almost no difference, but for some combinations the difference could be very important. And you have also here different combinations of degree 3 that in principle, let's see if they are significant. So we can see that in the ANOVA table. So vehicle type is very significant, gearbox is very significant, vehicle type and gearbox also. But then we have a month of or we have this one that is vehicle type and month of registration. This we already saw. This is the interactions of the two. But then we have the interactions of the three. So the interactions of the three, they are also very important. The order I'm following is by descending f. So the most important variable is the one with the highest f, and then the second one with the second highest f is the second most important, and so on. So we have here the third order interactions, and then the month of registration is really contributing with very little. Actually, this month of registration, once we have taken into account the interactions between vehicle types and month of registration, they explain really little. And the same happens with this one. So you can see here the month of registration, this is 10 to the 9, this is 10 to the 9, and then this is only 10 to the 8. And yeah, so now we know how to read the ANOVA table. There are some other important information that is the one given by the fetal M. So fetal M, we are already familiar with those. So we have here the in all interactions, and so let's see. So we have the intercept, and then the contributions by each one of the different kinds of cars, and then the gearbox. And we already know that the gearbox is we have manual and automatic, and we have only the contribution of manual because the one of automatic has to be uh, the negative of this one because they have to add up to 0. And something also interesting is that the estimates of fetal M do not need to be exactly the same as the fits of ANOVA N. So they are computing similar models, but the estimates of the parameters don't need to be exactly the same. And the reason is that the calculations that we use are slightly different. And then the month of registration, you see that it has been taken as a single parameter, so it has not been considered as a categorical value as it was in ANOVA. And here we have the different interactions. So bus with manual, cabby with manual, and then we have all kinds of second order interactions. Third order interactions remind that the combinations that do not appear, they can be automatically computed from the constraints of the interactions. They have to add up to 0 when you sum over any one of the indexes. So if you sum over vehicle type, the interactions, these three order interactions, they have to add up to 0. And then we have the p-values, and the p-values also tell us whether this contribution is significant or not. So the intercept is significant, all these are significant, probably not the one of vehicle type when it is a small car. The reason probably is that we have added so many parameters that the estimation of the p-values is a little bit compromised. And also that there is another interesting difference between these p-values and the ones of the ANOVA table. So the ones in the ANOVA table check whether all the vehicle types simultaneously they are 0. So not all of them simultaneously are 0. We can see that for some of them the differences are very important, but for the small cars the difference is not that important, so that we can claim that this parameter alone is really significant. So this is the main difference between the overall p-values calculated by the analysis of variance and the p-values per a specific estimate that is doing this model fit. The other one, the other interesting part is, okay, so using all the discrete variables, no matter how important they are, we are explaining 17% of the total variability. So the total variability, we see it is something like 10 to the 12. So we are explaining 15% or 17% of it. So it is around 1 or 10 to the 12, 1 times 10 to the 12. So something more or less like that. Okay, so let's see if we can do better. So that would be the presentation of ANOVA, but we now master other techniques. So we know, for instance, regression. ANOVA alone cannot handle regression. So let's see. I will present a different way of analyzing the data. We have not done this before. So the thing is to model the price as a function of some variables, and these ones are continuous. Okay, so let's see how well do we do. So if we do the fitting, we see here we don't have names for the parameters, but we know the order. So this is year of registration, power, horsepower, and number of kilometers. So all of them are extremely significant, and then the values. So for a particular car, let's say that we have a car that is from 2015. So the price would be this amount plus 500 times 2015 plus 53 times the horsepower that it has, and then minus 0.03 times the number of kilometers that it has. Okay, so that would be our way to predict the price, and with only those three variables, we see that we have a model that is able to explain up to 67% of the variability. So much more than with these other variables that are relatively weak. But then we have some residuals. Okay, so we can compute the residuals as we are doing here. So we use the model with these parameters to predict the price for each one of the cars, and then the residuals is equal to the true price minus the predicted price. And now we may try to explain the residuals as a function of the discrete variables, and we know that the important ones are these vehicle type, month of registration, gearbox, and I don't know if I'm forgetting any one of them, but it doesn't matter. You get the idea. So you can make a model with some regression, for instance, then compute the residuals, and then the residuals you try to explain with something else. And here it is. So what we have here is that now the total variance is still 10 to the 12th, but before it was almost 7 times 10 to the 12th. Now it is only 2 times 10 to the 12th. And then in this new model, we can explain part of the variability of the residuals that could not be explained by the year of registration, power, engine power, and kilometers. We can explain it by these variables, and they are not surprised. So the most important is vehicle type, and then gearbox, and then we have the interaction between vehicle type and gearbox, and all the others, they are kind of minor contributions. And then we can put all of them together. So we know that these three variables are important. We know that these other three variables are important. So now we may fit this model, and so we are explaining 70% of the data. We can see if by adding the interactions between vehicle type and month of registration, actually it would be better to put gearbox, so we can see if we can have a little bit better model. So just a little bit. So this has increased from 69.4 to 69.5% of the variability. So I think that the more complex the model gets, the more difficult it is to interpret. So let's keep it simple. So here we have what is the intercept, and then the different vehicle types, and the contribution of the year of registration, the whether it is manual, gearbox, or automatic, then the power, the contribution of the kilometers, then the contribution of the month of registration. It has been taken, as you see, uh, as a single uh, as a single parameter. So not every month acts differently, and all of the parameters are significant except this one of the bus, but all the others, they are significant. So yeah, this would be it for this example, and see you in class.